Hello, this is a presentation of PRES3. PRES3 stands for Privacy Preserving Record Linkage using services Spark and soundex. Our general goal was to create a system that will allow to perform record linkage on two different datasets and retrieve the produced matches of the operation. More specifically, the match data must also retain the privacy status, ensuring no sensitive information could be extracted from our transformation procedure. For our system architecture, we will be using a service-oriented approach, with each one of the services will have different role to our operation. The main reason of this architecture is to give as much independence as possible to our services in order to preserve privacy while moving away from a loosely coupled and monolithic system. Specifically, we will be using two base services to store our initial data sets that we want to perform the record linkage. These two services will also apply our transformation pipeline before moving the encrypted data to a third service. The third service, after retrieving the encrypted data, will perform a joint operation and return the matched data to the initial two services. Finally, the two services will communicate and send to each other only the weighted data. Regarding the data manipulation, we have created a service that moves the files to the correct directories, such as Hadoop distributed file system. For data processing, we have employed a Spark distributed cluster where we send requests to perform the requested computations. Finally, to make the application more approachable, we have created a user-friendly UI that is managed by the final service. Now, we will start explaining how our application works. For this demo, we have arranged a pseudo-distributed setup running all of our services on a single machine. We are going to describe the flow of operations as a data holder. First of all, we need to connect to one of the two base services and upload the dataset. We will be pressing from the menu the Upload File button, which will redirect us to a page where we can upload the file to our organization's HDFS. Now, we need to go to the Show Files page, where we can see the uploaded files and we can choose which columns will be transformed and which will be used to perform the join operation. We will choose to transform all columns and the field NCID to perform the join operation. Finally, by pressing the transformation button, we send the job to the Spark cluster and start the task. The second data holder performs the same process using the second base service. Now that we have uploaded and transformed data to both base services, we will deliver the encoded data to the third party who runs the join service so as to start the join operation. Also, when the Spark task from the previous step has finished, the final data will be transferred to the third service, which will run the join task. The join service runs on a different board. We go to the All Files page and choose which dataset we are going to perform the join operation and on which column as well. By pressing the join button, we set the new task to the join services Spark cluster and we wait for the task to finish extracting the matched data. After the join operation is over, the base services of the data holders get the match results and they can now send to each other only the correctly matched data. This is the end of presentation. Thank you.